Welcome everyone back to the YouTube channel. This old motor is out of the concrete mixer that Reese has been using, and unfortunately it's packed up, it's died. So anyway, I picked up this second-hand motor. It's actually from my father. He had it up in the shed, old one from something, not sure why. Seems to go quite well. However, there's one real problem with this, and that's it's spinning the wrong direction. So we need to reverse it so it spins in the right direction for the concrete mixer. Now for me, I find the best thing is to draw everything out so I can understand it better. So this is the way I understand it. You have a main coil like that, and it basically has a north and south pole, so it's technically got two poles to it, and then that's your main coil, and then you also have a starting coil, and that obviously has a north and a south on it as well. But and the reason why you have the starting coil is starting only, and it's phase shift out of phase, and I'll show you how that's done in a second. But so basically what we do is, we correct the main coil and the starting coil together and we call that the neutral side. And generally what we do is we call the main coil, we have the terminals in a modern standard are U1 and U2, and on the starting coil it's a Z1 and Z2 in general terms. And then what we have is we have the phase, single phase up into the main coil, and then what we have is a capacitor, which is what that is, and a switch. So we have a switch, generally it's a centrifugal switch, and a starting capacitor. So what happens is the capacitor actually phase shifts the phase coming in to basically get this thing started. So it's all round, and as it comes, it pushes a slightly different phase angle, and it helps move it. And in fact, if you want, we'll just hear, you can hear the centrifugal switch in this motor turn on and off. You click, you can hear the centrifugal switch go out. So that's pretty much the easy way of explaining, I think, an easy way of explaining a single phase motor. And if you want it to reverse, the easy thing to do is swap these two terminals over. So the U1 goes up there and the U2. So the U2 and the Z1 go together, and then the U1 and the Z2 would actually be connected together. So that's pretty straightforward. So now we're just going to pop into this motor and see what we can find about swapping all this round. So I just want to point out to everyone which way the motor is spinning at the moment. And so we're going anti-clockwise at the moment. So we want the motor to spin clockwise. Make sure you unplug it. Right, what we can see in here is not really what we're expecting. We've got an AZ there, we've got an A there. Something else down there. Lots of wires, nothing's really clear at all. I think this one down here is a T. So that sort of doesn't really line us up with anything of in what you'd expect in a normal motor, a modern motor, because everything's labelled a bit better. On the back of the cover, interesting, it has a little bit of something, but again, none of these colours seem to line up with what's there either. So we're a bit kaput. So really the only way to do this is to actually pull the motor apart and actually figure out where all the wires go. So that's what we're going to do next. So here's the switch. So when this is flipped over, it's pushing against this thing here. So it's actually pushing that down. So if we just hold the multimeter across that, we're getting nothing. We push that in, you can probably hear we get our own resistance, but when it's out, nothing. So as that flipped over, this here is pushing against this part and it's holding the switch in, and when this starts spinning, the weights pull it and push that down, and obviously then the switch comes undone. So that's how the switch works. So what we can deduce from this is one end of the switch is yellow and the other end goes up the top here, which we can find goes to the black. So one of those blacks we're calling will be the auxiliary starting winding. Right, so I've worked this out. In respects, we've got the AZ there, which has got the black and the red on it, plus an orange. So we're calling the black and the red. The red is the main coil, and then we've got the black, which is the secondary coil, and we're calling that code AZ. There's also got an orange onto it, you see here, an orange, which also, another orange comes out down on the R terminal down the bottom, but that just goes to this reset button. So flip this over, you can see the two oranges go to this reset button. So that, and then the live actually is connected to that. So actually this down here is actually the phase, not the negative. That's all right, that's the phase, and we'll call this the negative up here. It doesn't actually matter which way around the phase and neutral is. So we got that, and then the other side we've got here, which is the neutral, which is connected to the red again, and the white, which is the other end of the capacitor. So up here, A is connected to the neutral, we've got the red, which is the main, and then the white goes off to the capacitor. The capacitor on this drawing and the switch is the other way around, but that's all right. So to make this go in reverse, all we got to do is swap the two red wires from the A and the AZ. So from my determination, all we're going to do is swap the two red wires over, and we should get it going in the opposite direction. Yeah, I see that the red wires are well terminated. No, no lugs on them. They're just a piece of wire. So now we've swapped the two reds over from AZ to A and put everything back the way it was. Now we just need to push this motor back in. There we go. And now we'll just check to make sure that that is going in the opposite direction. As you can see, it's going clockwise, and before it was going anti-clockwise. If you wonder what Reese is up to, this is what he's up to. Making rocks. It's going that way, which means it's going clockwise.
throw the ugly ones back in next time I do the next batch. There's a bit of something.
Without showing you too much, here's the finished product of what Reese has been up to. And I won't show you everything, but that's the next video. Right, so this is the old motor off the concrete mixer. And so Reese was saying this was just tripping the RCD out, so obviously there's an earth fault inside the motor somewhere. So we're just going to pull this one apart and see what we can see and see if we might be able to fix it or throw it away, it's junk. So and then the problem is here, this lead is actually very much, both of them are pretty shot, main coil leads. I don't think that's going to be too hard to fix though. Put a bit of heat shrink over that, we should be pretty good to go. So here we can see here, this one is actually quite badly broken there, and that could be causing a problem. These are both very old. But first thing, so those are the two main coils, and the other two wires that you see in here are the auxiliary coils. So that's the auxiliary coil there, and that goes through this switch, which is actually driven again by the centrifugal clutch that springs out. So when it's not sitting, when that's sitting like that, that's pushing on that and pushing the contact to the auxiliary coil to go, which is through that lead, and that actually joins the positive element. And then obviously when that goes up, then this comes back, and basically that stops connecting. So push down, it's connected, and when it's back, it's not, and that does nothing when it's connected to the back. So that's how that works. But before we do that, we're just going to test some ohms through the and see if we can see any shorts. What we'll do first is just check, make sure there's not a short to the case on either of these, because if that's the case, there's obviously a broken wire somewhere, and I don't seem to be. So that's good. Now we can ohm the coil out to see if that's fine. So yep, that's 7.8 ohms, and that's good enough. And we can do the same thing with the auxiliary coil, which should have a slightly higher resistance. And it's got 16, so it's twice the ohms as the main coil, which is what you want. So the auxiliary or the starting coil should be have more ohms. It's yeah, it's the way it works. So those seems to both check out. So I think the main thing here is that we've got some broken insulation going from these two main coils to the main coil, which just sits in there. And if we just cover those with a bit of heat shrink, I think that will probably fix the problem. This is just cracking and breaking off. It's very old. Obviously, once it gets into the coils are not actually insulated. They're just air gapped everywhere. But these pieces getting in obviously go over the thing and next to that. So we'll just quickly do that and see what happens. So I've got a little box of heat shrink here. Biggest problem was we still got to get over top of the ring. Obviously you get too big a heat shrink, then it won't shrink down over top of the wire, which is no good either. I'm not sure you're going to get a, because this obviously will fit over, but it's way too big and won't shrink down when it's used shrinked. And I'm worried that that's probably a bit big. And there's something in between, something like that. Something like that will work. Got the white one here. The green one. What else we got? A couple of green ones of that size. A couple of white ones. Okay. That's probably going to work. The auxiliary ones seem fine. They're actually rubber or rubbery. And then these were like a very brittle anyway. I can't actually see any good reason why this won't work. The coils weren't earthing out and they ohmed out correctly. It was just that those wires going to the coils, all the insulation had broken off them. So I'm quite confident this is going to work quite well. Should work. And we'll have a spare motor since we got the other one working in the right direction. Now the thing to remember here is obviously I could actually get this to spin in the wrong direction. Those are the main coils, and depending on which way around they are compared to the starting coil, it could go backwards, but we already know how to fix that from our previous information that I showed everyone. So it's basically just got to flip these over, the main coils over compared to the starting coil. Now the coil, now the cable from this motor we actually stuck on the new motor, or new old motor. So I don't actually have a motor for this one. So I don't actually have a cord for this one at the moment. So we'll make up a new one. Some old lead I had. These are for crimping stuff. I see a lot of people just using plain old these and they squash them as hard as they can. These ratchet ones are far superior and make life so much easier for anyone. So you're buying a pair of crimpers, buy a pair of ratchet ones. They will make your life so much easier when crimping. I see people like struggle away when they're crimping and they're like, you just can't get anywhere near a good connection as a ratchet one, or amount of pressure on it as a ratchet one. It's so easy. Don't struggle. That's my motto there. The earth was actually on the outside, which is fine. So we'll just do that as well. That means the case will always be earth, which I think is quite good. Can't get. But running anything outside, you should definitely always run some sort of RCD protection, and therefore not only are you protected for some other faults, but you also, I mean, your MCB that you have in your house or your fuse is a direct direct fault, but if you've just got a little bit of residual current going through, that's when RCD works very well, so you should always use one of those. Right, see if it goes. What pops something. Problem is it's going to roll, isn't it?
It's a good one. You're brave enough to touch it.
Well, if it was live, it's earthed. It is earthed. The earth leads right on there. And the resident resident can't. So there we go, fixed. Well,
That was still a goodie. It just had lost its insulation.
yeah. So we got a spare one now.